Alright, today I wanted to give you guys a quick review on finding the domain of a function. This first video will be a basic video on finding domain, and the second video will be finding domain whenever we're combining functions or looking at addition or subtraction and or composition. So first off, domain. I think all of us know domain of a function is the possible x values. We've done a lot of studying this year on, say, quadratics or other polynomials. So here's an example polynomial for you, f of x equals x squared plus 2x plus 3. The way to figure out a domain is to first assume that all x values work, and then look to eliminate ones that don't. So for any polynomial, as we learned in Chapter 7 and in Chapter 5, polynomials have a domain of all real numbers. As we look at this function, there's two big things we want to look for. Is there a division by 0 anywhere? For instance, a denominator where a variable appears, or a square root with a variable underneath. And in this case, we don't have either, so we would say that the domain of this function here is all real numbers. Now, moving forward though, if we then see a function such as a basic one like f of x equals 1 over x plus 3, we now see that we have a variable in the denominator. And when there's a variable in the denominator, we got to make sure that we can account for that and eliminate it from the domain. As you see here, when we look at the denominator, x plus 3, we can set that not equal to 0, and we get x cannot equal a negative 3. Sometimes a domain will have more than one value that has to be eliminated. In this case, there's only one possible value. If I were to substitute negative 3 back in, I would have 1 divided by 0, which is not possible. So the domain of this function would be negative infinity to negative 3 union negative 3 to infinity. Continuing on to the second slide, if we then have a function f of x equals the square root of, say, x plus 5. Underneath a radical, we can't have negatives. We just finished up learning imaginary numbers, and as you learned, sometimes a quadratic would have imaginary roots, and that never crossed the x-axis. We didn't have a way of graphing them on an xy coordinate plane. Therefore, we have to figure out these values because they won't be able to be graphed on a typical Cartesian coordinate plane. So in a case like this, when you have a square root, what we want to do is we want to take what's underneath the radical, so in this case x plus 5, and we can set it greater than or equal to 0. In this case, what we're doing is we're actually solving for the possible domain. This will guarantee that what's underneath the radical will be equal to 0 or greater than. So when I solve this, I have x greater than or equal to negative 5. If I think about this, greater than or equal to negative 5, I think about just equal to negative 5. Plug that in. Negative 5 plus 5 is 0. Square root of 0 is 0, and that's perfectly okay. However, if I were to plug in a negative 6, I would have the square root of a negative 1, and there is no way to graph that on a Cartesian coordinate plane. So I can take this inequality and I can write it as my domain. The domain is bracket, because it is included, negative 5 to infinity. Now, moving forward from what I can do now is I can look at a combination of the two. F of x equals 1 over the square root of x minus 3. Now, whenever you have a radical that applies in a denominator, what we have to do is we have to keep track of both of the topics we just talked about. One is in the denominator, you can't divide by 0. So this right here can't ever equal 0. And it also has to be greater than or equal to 0 if it was underneath a radical. So combining the two together, underneath has to just be greater than 0. So we take x minus 3 greater than 0. Sorry about that, my cell phone went off. And then what we want to do from here is then solve. So we add 3 to each side. x greater than 3. And as a domain, it would be 3 to infinity. And once again, if you're not sure, if you're having trouble, there's always a way. You can set up a number line to write this out. You can take your inequality, write it on a number line, 3 with an open circle, and shade to infinity. And this may help you as domains get more difficult. But those are the two things we're looking for. The next video will be a little bit more difficult when we start combining functions.